Hello and welcome to our first lesson on quantitative analysis. This is all about working out the quantities of chemicals in a solution. And firstly we need to look at how we measure quantities in chemistry. Quantities in chemistry tend to be using the units called the mole. Now you may have heard of moles as an animal, but here a mole is a completely different animal. The mole is how chemists calculate the amount of something. Now things are a little bit difficult because all atoms differ in their mass. That's shown by the different mass numbers on the periodic table. In chemical reactions, we need to be able to add the required number of atoms with other atoms. And this can be difficult because something like oxygen, we have very light atoms. Something like lead, we have very heavy atoms. So we can't just weigh them out. If we weighed 10 grams of each out, we're going to get less atoms in the lead than we have in the oxygen. So because of this, we need a measurement which is about the number of particles and not the mass. So number of particles is really important. Now, chemists have worked out a measurement called the mole, and 1 mole has 6 times 10 to the power of 23 atoms. So 6.02 times 10 to the power of 23 is a very, very, very big number. It's like millions and millions and millions. And another word for this number is Avogadro's number. I call it avocado's number. You don't need to remember that amount and that name, but you do need to know that a mole is all about a measurement of how many particles there are. Now we need to be able to calculate a mole, and we use this formula here, N equals M over big M. Now if we put that into a triangle, remember whatever's on top of any division is in the top of the triangle. This is applicable as little m is grams, big M is grams per mole, so those mass numbers on your periodic table are telling you how many grams there are in 1 mole of any one of those elements on the periodic table. And N, little n, is measured in moles. So a mole is a little n. So let's remember that by picturing our little mole character here, whose name is Nigel the mole. And he's got a little t-shirt on, and on that little t-shirt is a little n. So that you'll remember now that moles has the symbol little n. We're going to put this into practice now. Now, as we said, in order to calculate moles, we need to have mass of the substance we're trying to calculate. How many grams of it do we have? And we also need to work out the molar mass. So our first part of this calculation of moles is working out how do you calculate the molar mass. And remember, it's in grams per mole. And we find it on the periodic table as the mass number. So say we're trying to work out the molar mass of HCl. We would write that big M HCl, so that it's clear on our paper what we're trying to do here. So we want the molar mass of HCl. You look at the periodic table, and the molar mass of hydrogen is 1. So we're going to have 1 plus the molar mass of chlorine off the periodic table is 35.5. So 1 plus 35.5 equals 36.5 grams per mole. So we're simply adding up the mass numbers of something in a compound. So for H2O, because we've got 2 hydrogens in it, we're going to multiply the molar mass of hydrogen, which is 1, twice, because there's 2 of them. So now instead of 1, I can HCl, we have 2. The molar mass of the periodic table for oxygen is 16, so we're going to add 16 and 2, and we can have the molar mass of H2O. So the molar mass of H2O equals 18 grams per mole. Now you can write grams per mole like that, or you can use this notation, which is the modern way of doing it. It's just some computer programs like this one, it's difficult to put the -1 up here. Okay, so remember to use the -1 or the slash, not both of them together. So now that we know how to calculate the molar mass, we're able to calculate moles. So we get our formula. A good memory jog for the formula is Nessels equals M and M's. Okay, so it's a little m at the top and a big M down the bottom. Remembering the little m is mass in grams, and the big M is molar mass in grams per mole, and little n is Nigel, our moles. Okay, so here's a typical question. How many moles are in 20 grams of water? Okay, so we've got 20 grams of water. So let's write down what we're trying to find out. We're trying to find out Nigel. So we're going to go N equals M over big M. And we're trying to work out N of H2O equals the little m, the mass. It's that 20 grams from the question. And the molar mass of water we worked out before was 18. So 20 over 18 grams per mole equals 1.11 moles. So if you look at this units here, because we've got grams on the top and grams at the bottom, they cancel each other out and we end up with the units moles. Doing that one more time, here's another question. How many moles are in 20 grams of carbon dioxide? Okay, so we want to find the N of carbon dioxide. It equals little m over big M. Big M is holding up the little m. We know that the mass is 20 grams, and we want to find the molar mass of carbon dioxide. So for carbon dioxide, if we look at the periodic table, the mass number is 12. For oxygen, it's 16. So because of the formula, we want 12 for the molar mass plus 16 times 2. All up equals 44. So our number of moles is going to be 20 over 44. Okay, we've had 2 practices, and in your workbook you're going to now have a go yourself at doing these during class.